Hello guys, welcome back to this channel. In this video, I'm going to talk about digital delay timer relay. This is the digital delay timer relay. This is the coil, and this is the base or the socket. We have 8 terminals or 8 contacts. And over here is the wiring diagram of the digital delay timer relay. And a digital delay timer relay is an electronic device that controls the timing of an electrical circuit. This is the display, and over here is where you are supposed to set your on delay and off delay time. And this type of timer has multiple time range. That is, you can actually set it in seconds, in minutes, in hours, or even in milliseconds. It is very special. And over here you could see that you have S at the middle here, and this side we have 2 zeros, and this side we have 2 zeros. Now we have buttons. This is a minus button, and this is a plus button. All the down buttons are plus, top buttons are minus. So if I push this minus, it is going to deduct, and if I push this plus button, it is going to add. So when I push it, it's going to add 1. When I minus it, it is going to subtract 1. And this S simply means a seconds. If you want to set your time in seconds, this is the S. If I set here S, this is where you are supposed to set the seconds. If I tune it to minutes, this is where you are supposed to set your minute. Have hour, this is where you're supposed to set the hour. That is the H, hour, M, minute, and S. And where is the milliseconds? We will find out at the end of the video. Now, when I push this plus button, it's going to add 1. And when I push this plus button here, it's also going to add 1. Let's say 2. So this is actually 1 hour 20 minutes. If I set this side M, this is 1 minute 20 seconds. If I set here S, 1 second 20 milliseconds. That is the way it works. And I actually have my 2 lamps here, of which I'll connect it at the end of the video, and also a contactor. This is the contactor. We are going to use the on delay and the off delay at the end of the video. So at the end of the video, you'll be able to know how to connect the on delay time and off delay time to a load. That is that. And without wasting much time, let's get started with the wiring. And it is very important to take note of the wiring. This is the wiring diagram, and I've actually drew it here to have a clear view. It is the same thing I've drew over here. We have the source, that is AC, DC. We have 12 volt, 24 volt, AC, 36 volts. We also have the same ratings over here. We have a lot of different voltage here, that is either AC or DC. And you could see that we have circles, and some of the circles has been shaded. Have it at this side. This is the source. We have AC. The AC has been shaded. This is the circle. This is a circle. This is a circle. AC has been shaded. And when you come to the down here, you could see a contact. Or at the middle here, you could see that we have 220 volts AC shaded. It means that before we will be able to energize the coil of this timer, you have to supply the coil terminals with 220 volts AC power or AC voltage. And you have the contact, that is the 5 amps. That is the maximum current rating, 5 amps. You can also see that we have 250 volts AC. This is the single phase voltage. That's the maximum. You have 220 volts over here. And you also have this 250 volts AC. That is the maximum. Right now, I'm coming to connect this digital delay timer to this load, a lamp. And if the current rating of the lamp is more than that of the 5 amps, I have to use a contactor. So guys, that is that. If your load has more than this 5 amps, you have to use a contactor to control that load. Now, these different types of voltage you see here, it actually means that you could have a timer relay that could be in 12 volts, 24 volts, or even AC 36 volts, or AC 380 volts. So whenever you are going to buy this type of digital delay timer relay, how to actually look at the coil voltage, it is very important. You could see that we have the plus and the minus, and the plus we have this sine wave under it. We also have a sine wave at this side. You have everything here. You have a plus and a minus, and you have a sine wave. If it is a DC voltage, this is the where you are supposed to connect the 7, where you are supposed to connect your positive cable or the positive wire to number 7. And number 2 is where you are supposed to connect your negative if it is a DC voltage. And at the same time, if it is AC, number 7 is where you are supposed to connect your live, and number 2 is where you are supposed to connect your neutral. That is that. So what you are about to do right now is to connect the live to number 7 and the neutral to number 2. And you could also see that we have number 8 and number 1. Number 8 is linking directly to number 5. And the same number 8 is linking to number 6, but it is normally open. And the number 5 is normally closed. You also have number 1 linking directly to number 4. And the same number 1 linking to number 3, but this time around it's normally open. So if I want to use this side, the number 5 and number 6, I have to supply a current. These are common terminals. The number 1 and number 8 are common terminals. So if I want to use any of these terminals, the number 5 and number 6, I have to loop the live that I've connected to number 7. I have to use a jumper, a piece of cable, and loop the live from 7 to 8. If I want to use this side, the normally open and normally close at this side. If I also want to use the normally open and the normally close at this side, I have to use number 1. Loop the live either from the breaker or from the number 7 to number 1 before I'll be able to use this side. And when you see a triangle at this side, it means that you can use this type of normally open and normally closed to set your on delay and the off delay time. When there is no triangle, it is also a different thing. I have this type of timer here. With this one, you could see that you have a triangle at this side. But this side, you don't have any triangle. It is a different thing altogether. So always have to check your drawings very well. And I've made a video about this type of timer relay. And I'm going to leave the link in the description down below. You only want to focus on this one. So if you are interested in this, you can actually check the description for the video link. You tap on it, it will take you directly to that video. To watch it, I've explained this side and this side. So it is very important to take note. And when you see this side, as I said, it means that you can use this side for your on time and the off time, and this side too for the on time and the off time. You can also see that we have this drawing here. We have something like a hole. This is a key or a locker. This type of delay time, others can call it 8-pin or whatever. It is the same thing. Now, when I want to insert it into the base, I have to look at this bar we have here before I'll be able to insert it. Something like a guide is going to guide you to insert the pins into the right port. So anytime you are inserting the coil into the base, how to look at this before we're able to insert it. If you don't look at it, you might actually interchange it and it will not work. So I have to look at it. What you are coming to do, as I said, is to connect power from the breaker to the relay, the base. And the base, these pins are what is going to link the power to the coil. So without wasting much time, let's get started with the wiring. And this type of delay timer is very special because you can actually set it in hours, in minutes, in seconds, and even milliseconds. It is very special. So what I will do is to connect my live and neutral to the base. This is the circuit breaker. I have the live at this side, and this side is the neutral. So what I will do is to connect the live to number 7. This is the live. The red cable as my live and the green as the neutral. Okay. To number 7, we have number 7 at this side. This is number 7. What you could see on the base are numbers and contacts. We have numbers here. We have numbers here. So whenever you want to connect a cable to a terminal, you have to actually check the number to know what type of terminal you are actually connecting your load to. It is very important. So I connect it to 7. This is number 7. The green to number 2. As I said, I want to use number 5 and number 6. Number 8 and number 5 are normally closed. and the same number 8 and number 6 are normally open. Those are the terminals you are going to use to set the on delay and the off delay time. And when we say on delay means that your load is actually going to turn on, but it is going to delay. That is the on delay. It will turn on, but it will delay before turning on. And that is the normally open. It will turn on, but it will delay. And you have the normally close. It will turn off, but it will delay. That is the off delay. So automatically, when I connect everything and turn on the breaker, automatically the timer relay is going to start counting. And if I set it to, let's say, 30 seconds, when that 30 seconds reach, then the normally close will tend to open and the open will tend to close. So with the normally close, it is going to be off delay. It will go off, but it will delay. And the normal open is going to be the on delay. It will turn on, but it will delay. So automatically, when I turn on the breaker and the coil receive its right voltage, that is the 220 or 250, that is the maximum, it will start counting automatically. And when the preset time reach, the time that I've set, when that time reach, the close is going to tend to open and the open is going to tend to close. I want to use this side there, number 5 and number 6. So what I will do is to loop the same 7, the live at number 7. I have to use a jumper to loop it to number 8. So I use this red cable. This is a jumper. I will connect it from 7. I have 8 at this side. So right now I've looped the live, the common terminal, number 8. And before a lamp works, there must be a neutral and a live. So what I'll do is to connect the neutral from this side to the lamp holder. I'll be using these 2 cables as my neutral. This one to this side, and the same neutral I will loop it to this side. So guys, what you have to do now is to connect this lamp holder to normally open. So I'll make here NO, and this one normally close, NC. Okay, we are left with the switch wires, and this is normal open. We are going to connect the normal open, the number 6, to the lamp holder. We have 6 at this side, so I'll pick 6 from this side to this terminal, and number 5, that is the normally close. You have 5 at this side, from 5 to this side. Those wires are the switch wires. That is what is going to turn on the load. I have the neutral connected already. So I use this cable and connect from number 6 to the lamp holder. This is number 6. Number 6 is normally open. This is normally open. And as I said, this is a switch wire. This is also a switch wire. To number 5. This is number 5, normally close. Guys, you are successfully done with the connections. With this normally open and a normally close, when I turn on the circuit breaker, automatically the timer is going to start counting. And before the timer starts counting, the display to start counting, I have to set my on delay and off delay time. I have 2 loads connected to the normal open and the normal close. So I have to set the on delay and the off delay time. So I have to set it first before I turn on the circuit breaker. So what I have to do is to set 3 seconds. That is the preset time. 3 seconds, let's say 30 milliseconds. This is actually S, meaning seconds. If I push the plus button, M, meaning minute, here becomes 3 minutes 30 seconds. If I set to H, here becomes 3 hours 30 minutes. That's the way it works, or that is how to read it. So I'm actually going to set it to S, that is seconds. 3 seconds 30 milliseconds, and insert it. And as I said, the moment I insert it, it's going to start counting. I have to actually look at this bar we have here. This is a guide, so you're going to guide it to insert it properly. Okay, these are screw types, so I have to screw it all the way down. and when I turn on the circuit breaker, the normally close is going to start working. That is the lamp. It will illuminate, or it will bright. So the normally close will start working before the normal open. I will turn it on. Now the normally close is working. Okay, right now it has run to 3 seconds, 30 milliseconds. Let's say 5 seconds and 90 milliseconds. So right now the normally open is working, and it is not going to stop working. If it is a motor, it is not going to stop running. How to actually turn the switch off, or the breaker, or the push button, how to turn it off. I've set it to 5 seconds, 90 milliseconds. Now when I turn on the breaker and the load starts working, there is no way I can change it. I have to actually set it before turning on the switch or the breaker. That's the way it works. Let's say I've turned it on and I want to make changes. It is not going to affect it. Let me set an example. 3 seconds, 90 milliseconds. I turn it off. I turn it on, make it 0. It's not going to affect it. You have already programmed it, so nothing is going to work. So this side is actually in zeros, and this side is 90 milliseconds. This is S, so here is 90 milliseconds. So when I turn it off and turn it on, it is actually going to run it in milliseconds. Look at it. That's the way it works. When I set it to minutes, here becomes seconds. Look at it. You see the way it is running? Here becomes seconds, or here becomes seconds. That's the way it works. So right now the normally close is working. Whenever you use the normally close and the normally open terminals and you turn on the breaker or the switch, the close is going to start working, and when that preset time reaches, then the close will go off and the open will take over. That's the way it works. The moment you turn the switch on, the breaker or whatever it is, the moment you turn it on, the close will start working automatically. And when that preset time reaches, then the load will go off and the open will take over. The normally close will go off and the normally open will take over. That's the way it works. So I've set it to minutes, and this side is 90. So it's supposed to run for 90 seconds. As I said, I'm actually going to connect the contactor. This is the contactor. I'm going to connect it to it to see how it is going to operate. Now when I make changes, it will not work. That's the way it works. It will not work. This is 90 seconds as I said before, and I've actually changed it to 98 seconds. It is not going to work. Here is seconds is because I'm supposed to push any of this to set the minute, but I've actually set it to 0. So this side is rather going to run. And what if I make it 0, 0? What is actually going to happen? Let's see. This is 0, 0. Now look at it. The normal open is going to work. When you set everything to 0, the normal open is going to work. It is not going to run for anything, the normally close or the normally open. Automatically, when you set everything to 0, and it is either minutes, seconds, or hour, it is going to run. The normal open is going to run, and the close is not going to run. Look at hour, the same thing. Minutes. It is the same thing. So when everything is in zeros, the normal open is rather going to work. The normal open terminals. That is the number 6. I use this side, so I connected the live. I loop it to number 8. So if I want to use this side, I can actually loop the same live to number 1 before I'll be able to use this side. Now let me connect this contactor to it, to the normally close, to see how it is also going to work. So we have the neutral, the green cable. So what I'll do is to connect the green cable to A2. That's the neutral terminal. Okay, I turn it on. This is in 0, so it will not work. The normal open is rather going to work. So what I have to do is to set, let's say, the seconds is very fast, so I like using the seconds, but the minute, the hour. It is the same principle. This is 3 seconds, 10 milliseconds. Turn it on. That's the way it is going to work. So whenever you are using one load, right now I have two loads connected, a lamp and a contactor. So whenever your load is only one, just connect it to the normally close. With the normally close, the moment you set your preset time and turn on the circuit breaker, the close is going to work. And when that time reaches, the preset time, the close is going to turn off and the open will take over. And you can actually connect it to the normal open and it is going to work. It is the same principle, but it will work best when you connect it to the normally close. So guys, that is that. And as I said, I have a video about this type of timer relay. This is 8-pin. You can actually call this one to 8-pin. It is the same thing. The only thing different here is that this type of delay timer, you have triangle at this side, another triangle at this side. But this one, you only have one side. And I've made a video about this type of timer delay, and I'm going to leave the link in the description down below. Now let's look at this. Let me set it to, let's say, 10 seconds to see how this is going to work. This is 220 volts, and it is okay when I connect it to this base. When I turn the circuit breaker on, this on indicator is going to turn on, and the moment the contact change, that is the normal open turns to normal close and the normal close turns to normal open, this up here will also light up. Now let's see. 10 seconds. The contactor is running. You see the on indicator. Okay, so guys, that is that. And as I said, this type of delay timer is totally different. I've made a video about it. I'm going to leave the link in the description down below. Just go to the description and tap on the link. It will take you directly to this video to watch it. So guys, if you find this video helpful, consider subscribing to this channel and turn on the notification bell so that anytime I drop a video, YouTube is going to notify you. Thank you for watching this video and see you in my next video. Bye.